All right, so Java. And in the world of Java, you can't really avoid this massive thing, this framework called Spring. It's kind of everywhere, right?
Right.
But if you're like just starting out or even if you've been around for a while, Spring can be a little intimidating. It's like, where do you even begin?
It's true. It's a bit like, I don't know, trying to eat an elephant. You kind of look at it, you think, where do I even take the first bite?
Exactly. So for this deep dive, we're doing things a bit differently. We want to give you that express lane, that shortcut, to really understanding what Spring is all about. What are its strengths? Why is it so popular? We're not going to get bogged down in like every single configuration detail or anything like that, just the core stuff, straight to the point.
Yeah, think of this as your Spring cheat sheet, basically. We've done the digging, gone through some key excerpts and stuff, and we're going to distill it all down for you. You're busy people, we get it. You want that knowledge fast, but you want it good, right?
Right. So where did this Spring thing even come from? It wasn't always the big name on campus, was it?
Not at all. You got to go back, like way back to the early 2000s, the world of J2E and EJBs. Enterprise Java Beans. The memories.
Yeah, I vaguely remember those days. Not exactly known for being simple and elegant, right?
Not really. It was. It was a lot of complexity, a lot of overhead. And then in 2003, Rod Johnson comes along and he's like, there's got to be a better way. And boom, he drops the Spring framework. It was like a breath of fresh air, a much lighter, more manageable approach to building enterprise Java applications.
But it wasn't just like a random idea he had, right? Didn't he write a book that kind of set the stage for all this?
You know your stuff.
Yeah.
Yeah, his book, Expert One-on-One, J2E Design and Development, that was a game changer. It didn't just point out the problems with J2E, it offered solutions. And two big ones that he really pushed were inversion of control, or IOC, and aspect-oriented programming, or AOP, and those became like the bedrock of Spring.
Okay, so just a quick reminder for our listeners. IOC, that's all about letting Spring manage the creation and dependencies of your objects, right?
Precisely. Instead of your code being all tangled up, trying to create everything itself, Spring takes care of that. You just tell Spring what you need, and it wires it all up for you. This makes your code so much easier to test, and when your project starts getting bigger, it's a lifesaver.
So 2003, that's the origin story.
Hmm.
But Spring didn't just stop there, did it? It feels like it's always evolving.
That's one of the things that's kept it relevant for so long. It's constantly adapting. So you had things like annotation-based configuration coming in around Spring 2.5, which was a huge improvement over the old XML hell we used to live in.
XML hell, oh yeah, I remember those days.
Good times. And then Spring 3.0 came along and brought in even more powerful Java-based configuration options. And of course, it kept up with the web, adding support for RESTful web services.
But it feels like there was a real turning point somewhere along the line, something that kind of propelled it into like the stratosphere.
You're thinking about Spring Boot. And yeah, that was massive. 2014, Spring Boot comes along, and suddenly building and deploying Java applications, especially microservices, became so much easier, so much faster.
Right, Spring Boot, that's what everyone's talking about these days.
Yeah.
But the core ideas, the IOC, the AOP, all that stuff from Johnson's book, that's still at the heart of it, right?
Absolutely. Inversion of control and dependency injection, that's like the DNA of Spring. It's what does it tick. The whole idea is that your code isn't bogged down with managing all these dependencies. Spring handles it, which leads to what we call loose coupling.
Loose coupling, meaning my code is more modular, it's more testable, it's just easier to maintain.
Exactly. And AOP, that's all about dealing with those aspects of your application that cut across multiple modules, things like logging, security, transaction management. Traditionally, you'd have to repeat that code all over the place. AOP lets you modularize that, so you can keep your core business logic nice and clean.
So IOC is about managing the what of my application, the components, and AOP is about managing the how of certain behaviors that apply across those components.
You got it. And beyond these core principles, Spring's got a whole ecosystem of tools, right? You've got Spring MVC for building web applications. We've talked about Spring Boot, which makes everything smoother, especially for microservices. Then there's Spring Data, which makes working with databases a breeze, whether you're using relational databases or NoSQL. Spring Security handles all your authentication and authorization needs. And then there's Spring Cloud for building scalable microservices with things like service discovery, API gateways, and configuration management.
It sounds like Spring tries to play nice with other tools and technologies in the Java world.
Definitely. It's not about reinventing the wheel. It's about integrating with existing, well-established libraries and frameworks. A good example is Spring's caching abstraction. You might want to use Akash for one project, Redis for another. caffeine for a third. Spring gives you a consistent API, so you can switch between these caching providers without having to rewrite a ton of code.
So that kind of flexibility is really valuable, especially in a fast-moving environment.
Absolutely. It plays well with others, whether it's JPA, Hibernate, Spring Security, Spring Cloud. It's like the connective tissue that holds a lot of modern Java together.
And that adaptability, that's a big part of why Spring has stayed relevant for so long, right?
It's huge. Spring is always evolving, always embracing new trends and technologies, and that, combined with its incredibly strong community, makes it a pretty solid bet for the future.
All right, so now that we've kind of got the big picture, the benefits, the history, let's zoom in a bit. Let's look at some of those fundamental building blocks that make Spring work. And one of the first things we encounter is this concept of bean scopes. So what are bean scopes all about?
Bean scopes, they're all about controlling how many instances of a particular bean spring creates and manages within your application. The most common one, and the default, is the singleton scope. Basically, this means there's only one instance of that bean for the entire application. Everyone who needs that bean gets the same one.
So that makes sense for things that are like shared resources, configuration data, stuff that doesn't need to be unique for each user or request. What are the other options, though?
Well, you've got the prototype scope.
Mm-hmm.
With this one, every time someone asks for a bean with that scope, Spring creates a brand new instance. So if you need independent instances, that's the one to use. And then in web applications, you have scopes like request, where you get a new bean instance for each incoming HTTP request, and session, where you get one instance per user session.
Ah, right. So the scope determines how long that bean instance lives and who gets to use it.
Exactly. And there are a couple of others, like application scope, which is similar to singleton but at a different level, and some more specialized ones. But those are the main ones you'll probably encounter most often.
And speaking of the life of a bean, Spring manages that whole life cycle, right? From creation to destruction.
It does, yeah. There's a whole life cycle that a Spring Bean goes through. First, you have instantiation. That's when Spring actually creates the bean object. Then comes dependency injection, where Spring injects all the dependencies the bean needs to work properly.
So that's where Spring is wiring things up based on what we've defined.
Exactly. Then you have post-initialization, which is a fancy way of saying you can have custom setup logic that runs after the bean is created, and then obviously the bean is used by the application.
Does it just die after that? Or is there more to it?
There's a bit more. Before a bean gets removed from the application context, you have pre-destruction, where you can do any cleanup you need. And then finally, destruction, where the bean is actually removed.
So Spring is really like a bean nanny. Takes care of them from cradle to grave.
Pretty much. And you, as the developer, have control over those initialization and destruction phases. You can define methods that Spring will call automatically, so you can set up resources, clean them up, whatever you need to do.
Okay, that's pretty neat. Now, let's talk a bit more about how Spring lets you add behavior to these beans without actually changing their code. And that brings us to aspect-oriented programming. We mentioned it earlier, but can we dig a little deeper? You talked about logging execution time as an example.
Yeah, so let's say you want to log how long every method in your application takes to run. Now, the old school way would be to go into each method and add logging code at the beginning and end. Tedious. Right?
Very repetitive. And it clutters up your actual business logic.
Exactly. With Spring AOP, you define an aspect, which is like a module that encapsulates this cross-cutting concern, in this case, logging execution time. And then you define join points, which are specific points in your application's execution where you want this aspect to be applied, like before and after a method executes.
So instead of changing every single method, I just tell Spring where I want this logging to happen.
That's it. Spring uses these things called dynamic proxies, either CGlib or JDK proxies, to intercept those method calls. So when a method that's been targeted by your aspect is called, Spring's proxy steps in, does its logging thing, calls the original method, and then logs again after the method finishes. And what's really cool is that a lot of Spring's own features, like the transactional annotation for managing database transactions or at cacheable for caching, they actually use AOP under the hood.
So you're not even seeing the AOP magic, but it's making your life easier.
Exactly. It's powerful stuff. You're adding behavior without messing with the original code. Everything stays clean and focused.
All right, now there's another term that we often hear in the Spring world, templates. What's the idea behind Spring's template model?
So the Spring template model, it's based on the template method design pattern. It's all about providing a reusable structure for common tasks, but letting you, the developer, focus on the specific bits that are unique to your application. Think of it like a blueprint.
Okay, a blueprint for like certain operations.
Right. And this helps reduce boilerplate code. It ensures consistency, especially for things like resource handling and error management.
Can you give me a real-world example of how a Spring template works?
Sure. JDB template is a classic one. If you're working with a relational database using JDBC, you know there's a lot of boilerplate code involved. Opening connections, preparing statements, executing queries, closing resources. It's a lot to keep track of.
Yeah, I've been there. Not exactly the most exciting part of development.
JDBC template basically wraps all that low-level JDBC stuff. It handles the connection, makes sure resources are closed properly, even converts those checked SQL exceptions into more convenient runtime exceptions called data access exceptions.
So I don't have to write all that connection code every time I want to do something with the database.
Nope. JDBC template takes care of it. It gives you simple methods for common operations like query for object to fetch a single record, query for a list to get a list of records, update to do inserts, updates, deletes. It even supports prepared statements, which helps prevent SQL injection attacks and can improve performance.
So less code, easier to read, safer, potentially faster. Sounds like a win all around.
Definitely. And the same principles apply to other Spring templates. For example, JPA template does something similar for JPA, which stands for Java Persistence API. It's a standard way to work with databases in Java. JPA template simplifies those JPA operations and plays nicely with Spring's transaction management system. And speaking of transactions, Spring has a pretty sophisticated way of handling those, right? Especially when you're dealing with databases, you want to make sure things are done consistently.
Yes, transaction management. It's all about making sure your data stays in a consistent state, even if things go wrong.
Right. Spring gives you this robust transaction management system. There are two main ways to use it. The first is declarative transaction management, where you use the @transactional annotation, you put that on your methods or classes, and Spring automatically handles the starting, committing, or rolling back of transactions.
So it's like telling Spring, hey, this stuff needs to be done as a unit. Either all of it happens or none of it happens.
Precisely. And the second approach is programmatic transaction management, where you use a transaction template to explicitly define your transaction boundaries in code. But generally, the annotation-based approach is preferred because it keeps your code cleaner.
So we've got these transactions, but there are different ways they can behave, right? Like how they interact with other transactions that might already be running.
Yeah, that's where transaction propagation comes in. Spring gives you a bunch of options for how a method should behave if it's called within an existing transaction. The most common one is required, which basically means if there's already a transaction running, join it. Otherwise, start a new one.
So it's like jumping on the transaction train if there's one already going.
Then you've got requires new, which always creates a new transaction, even if there's one already running. It kind of puts the existing transaction on hold. And then there's supports, which will use an existing transaction if it finds one, but it won't create a new one if there isn't.
So it's more flexible, kind of goes with the flow.
And there are a few other more specialized options like not supported, mandatory, and never, and nested, which deal with more specific situations around transaction boundaries and error handling.
So a whole toolkit for controlling transactional behavior. And then on top of that, we have isolation levels, right? They're all about preventing data inconsistencies when multiple transactions are happening at the same time.
Exactly. Isolation levels define how much one transaction is isolated from the effects of other transactions that might be running concurrently. Spring supports the standard SQL isolation levels.
So we've got read committed, repeatable read, and serializable, each one offering a different level of protection against those concurrency issues.
You choose the isolation level based on what your application needs. It's a trade-off between concurrency and data consistency.
So wow, we've really covered a lot of ground here. From the history and the core principles of Spring to its main building blocks like IOC, AOP, and Spring Boot. We even delved into things like bean scopes, the bean lifecycle, AOP in practice, the efficiency of Spring templates, and its powerful transaction management system.
It's been a whirlwind tour, but hopefully a useful one. We've seen how Spring emerged from this need to simplify Java EE development, how IOC and AOP offer a more elegant and maintainable way to build applications, and how tools like Spring Boot and those various Spring templates can make developers so much more productive. And of course, we can't forget about that robust transaction management system that keeps our data safe and sound.
And for you, the listener, I hope this deep dive has given you a much better understanding of Spring. It can seem like this huge monolithic thing, but when you break it down, it's all about these elegant ideas and powerful tools that help us build better software.
And as you go forward, think about this. Those core principles, like IOC, that idea of separating concerns and managing dependencies, it's not just a Java thing. You can apply those ideas in all sorts of contexts, even outside of programming. Maybe it's organizing your work. Maybe it's even something in your personal life. And who knows, maybe this deep dive has sparked a curiosity to learn more about specific parts of Spring. There's a whole world to explore out there.
And on that note, we'll wrap up this deep dive. Thanks for listening.
Thanks, everyone.